Okay, so today we are going to talk about the Gen AI solution that we've implemented for customer account management. We'll slightly touch upon the AI at scale and what we do at Schneider and the responsible AI guidelines that we have. We'll discuss about the implementation architecture and the major portion of, major part, which is what benefit and impact it. What was the business challenge that we were trying to tackle? So Schneider, when it comes to having different customers, so there are thousands and thousands of customers that get added daily to the system. So right now, there is this big Salesforce database that hosts this data, and once these thousands of account when they flow in daily, right? So they do not have proper hierarchy mapped out. So there's a very good example with Whole Foods, a Whole Foods chain in the US, right? So the parent company for that is Amazon, and some of the listings or some of the accounts that might come in is Whole Foods or Whole Space Foods or Whole Foods Corporation or something like that, right? So it's difficult to have this manually mapped out within the system uh, for these new accounts. So some of these accounts might have a parent and then they might have an ultimate parent, or some of these might have a parent who has another parent, and then ultimately they roll up to a big corporation, right? So, and these are all diverse geographies and subsidiaries. So, what happens is when we have a database like this of a million or more accounts, and with new accounts flowing in daily, if they are not mapped out correctly to the correct parent or the correct ultimate parent, what happens is it results in inefficient sales resource allocation. Some of these might, what we call some of these accounts, right? They might be in the system without a parent or an ultimate parent. We call those accounts as orphans. And our primary focus was to eliminate these orphans, because what happens with orphans is it results in limited customer targeting, uh, and there is a high administrative overhead, right? So someone has to manually go through these records to fix the parent and the parent ultimate parent hierarchies within the system, which results in resource overhead. So we get asked this question a lot, especially before the advent of LLMs, right? Why not go with traditional NLP models or text search mechanism to do this, right? So one of the problems is semantic matching failures, right? So if you see these examples, right? So one of them might be Globex INC dot. The other one might be listed as Globex INC within the same system, within the same database. Then there can be Acme Limited bracket US, then Acme Limited UK. Technically, all of them belong to the same Globex and Globex INC. Both of them would belong to the same parent. But in our system, these will get listed as different accounts. Some of them might even be orphans, depending on the special characters that are there in the account names. Spaces around the names, etc. So this would result in a highly inaccurate NLP search where there might be semantic matching failures, and the accuracy would be affected. So our solution was to use LLMs and vector embeddings for RAG. We implemented intelligent pattern recognition. We for the accurate parent-child relationships. The whole purpose of this solution and one of the key goals was to have this as a very dynamic auto scale architecture. So, it should scale rapidly, optimize the resources, and should be very cost efficient as well. So once we have this solution in place, it should also be like very easily integrate to the current systems that we have. There should not be a bottleneck there that this solution is very is complicated, so that we cannot write it back to the Salesforce database and cannot integrate with the current system that we have at Schneider. So this is the architecture. We primarily the resources that we use is AWS Patch, which is an orchestration tool built on top of Amazon ECS. This is primarily used for data processing. data load as well. Um, then we have our database as AWS Aurora Serverless V2, which also serves as our vector database. Of course, for the LLMs, we leverage AWS Bedrock. We primarily use Anthropic models as of now. Storage is S3, and Event Bridge lets us do the event management for the triggers. The application is hosted on our Amazon EKS cluster, which is then exposed, the UI is then exposed to the users. So I will talk in the next slides about different components within the same architecture. So the starting step, right? The data extraction and preparation. So the data for this is actually originally comes from a Salesforce database, which has the account information and the existing hierarchies. This is the same database where thousands of accounts flow in daily, and out of which some of them would be orphans that we process. So we have a AWS daily batch daily process. Now this Salesforce database is also hosted on a AWS Redshift cluster that we have. It kind of stages this data and it stages data from a lot of ERP within the system in the North America space. So we use that Redshift cluster to fetch that data using a batch daily process. Um, the daily process, once it loads this data into our Aurora database, it also flags the incomplete records. By incomplete records, I would primarily say orphans, um, accounts where you might have a parent but no ultimate parent, uh, accounts that might need a parent or a ultimate parent hierarchy updation. So there is the flagging mechanism in the batch process which flags these accounts for the daily run. So the output is Aurora Postgres, which has a structured account attribute data, um, and it also serves as our vector database. So embedding generation, this is one of the key things that we have for our vector database. So we currently use serverless V2 with PostgreSQL 15.3 as the Postgres version. Um, uh, we use the PG vector extension in there. As far as I remember, it's a 0.5.0 right now. We also use the Hugging Face sentence transformer model as our embedding generation model. So this process sits somewhere in the middle of the, after the data pull and before the LLM process kicks in. So it, whenever a new account flows in, embeddings are generated for those new accounts. If an account has something like an account name change, or there might be address change or a parent change or any kind of change within for that account on that data row, so the embedding process regenerates those embeddings and stores them into our database. So this is the AI processing flow. I will go through the details in the next slide, but essentially we have this big flow, which finally results in the final prompt, which is sent to Claude 3.5 Sonnet V2. So basically, what's the entire process, right? When it comes to LLM, so we do initials. So there are three sources that we verify this data from. So one is a Google search, and this API is known as a SERPer API. So this is a traditional Google search API that you can use to, find results via Google. So we do an initial search query through the SERPer query to gather the parent company information of a target account or of an account, right? Then these results are passed to Claude 3 for interpretation, where we send it for an initial, we send it to a LLM to, generate the prompt for us that, this is the information that we got from Serper. So we get the results from Claude after that. Then this same data is then passed to DNB, or the prompt is passed to DNB. Um, DNB is Dun and Bradstreet, which is an organization that provides you data and analytics solution. So they also have the data and they store this data for parent and child for various organizations. So we also fetch this data from Dun and Bradstreet API for the parent-child relationship verification. Finally, we do a vector search in the data that we already have. So there are three levels. So first is the Google search, second is Dun and Bradstreet search, and then the vector search. Once we have all this three information like in place, then we do the final prompt creation for recommendation. So we ask the LLM that, for this particular account, these are the Google search results. This is the result that we got from DNB, and this is the result that we have within our Aurora database. So, based on that, the LLM recommends that what the hierarchy of an account should be. So, the parent and the ultimate parent. Weightage is given to the data that we get from DNB because of the accuracy. The least weightage is given to the Google search results in this. Uh, so the model selection and evolution, right? So when we started out this with this solution, we have we were swapping out models from the first generation of Claude, right? We started with Haiku and then we went to Claude Sonnet V1. Then, currently we use Claude 3.5 Sonnet V2, which gives us from our testing and from the domain expert that we have who verifies these results. 3.5 Sonnet V2 has been the most accurate of all the models within Bedrock. The output generation is a formulated recommendation with a detailed reasoning chain that is shown to the user. Standalone accounts are flagged whenever applicable. So the orphan accounts which are flagged, if the LLM cannot find that result, or if Dun and Bradstreet Google, so those are flagged again within the system. So data integration. So what happens after the recommendation, right? So this recommendation is shown to the users using the UI that, with the logical reasoning, which is provided by the LLM on why the LLM generated this result from the information provided to it. Users retrieve this recommendation list daily and they go through this recommendation list and they approve or reject it based on what they feel is correct. Once this result is approved by the users, this data is then downloaded by some like people known as data stewards. The data stewards, they capture this information and they feed it back into the Salesforce system. So this essentially the data warehouse or lake update, what it does is like it updates the database data set syncs to the corporate data lake structure. So, it captures the three-tier relationship structure. Parent, so a child should have a parent, it should have an ultimate parent. That's the end goal. And once this process runs and ones that are approved, they ultimately end up with this hierarchy. So the key benefits here, right? So what was the advantage of having this elaborate setup? So there was a 60% reduction in the overall account hierarchy management costs prior to the manual, like how it was being done before, which is manually. The operational expenses are lower as well. So the services that we use are all managed AWS services. So it results in a lower operational cost. There are no EC2s to manage, or there are no standalone SageMaker endpoints to manage. It's all managed AWS services. Uh, from a timing perspective, right? This process reduced the timing by about 57%. So prior to this, each account, if done manually, it would take on an average 7 minutes per account, sometimes more, but the average timing that we've noticed is 7 minutes. With the current process, it's 3 minutes per account and it's improving. As new, faster models come up, this timing is improving on a day-to-day basis. This process would also involve like further improvements are expected with, since the data is being improved on a daily basis, right? So we expect that this data is going to get cleaner, it's going to better uh, with the process running daily. Also, with new LLMs coming in, we expect, it to be faster, it to reduce the timing, to be more accurate. So uh, Future evolution note, based on the results that we have provided to the stakeholders, we now have the approval and it's currently in process where we are doing a large scale implementation. So basically a full run on all the accounts that we have within our system. So by BFO, what we mean is our Salesforce database, which is named as BFO. So this, based on these results, we have started to run this on all accounts, orphan or not. And we are also moving towards direct integration. That is, no, like the user validation step would be, it would be a direct integration instead of having multiple users look at it and approve it. Like based on the accuracy that we have, there are ongoing talks about, direct integration to Salesforce after this exercise. So what are the technical advantages of our architecture? Model flexibility and optimization. So we can switch between cloud models very easily. And we have done that many times in the past. So we have we have used Haiku, we have used Claude Instant, we have used Sonnet V1. We currently are on 3.5 Sonnet V2. So we can easily switch the models based on when a new model comes in, like we evaluate the accuracy and we can make that switch very easily. We also have the ability to leverage multiple LLMs. So prior to this, we were actually leveraging two different LLMs. So the initial Google search and Dun and Bradstreet API, we were using a faster, less costlier model to prepare the prompt for us. But now we have switched over to 3.5 Sonnet V2 completely for like throughout the process. But we do have the ability to use multiple models. The architecture is highly scalable. It reduce hallucinations with newer models, of course, and there's enhanced data quality over time. So this is typically how the structure looks like on the UI. So on the left hand side, we have the child record. The middle one is the recommended parent by the system. And on the third side, we have the ultimate parent that we have. Now there can be multiple this way, like there can be four tabs as well. It depends on the hierarchy. So this one has a simple two-tier hierarchy, a parent and an ultimate parent. On the next screen, the user can actually look at the record and look at the recommended parent hierarchy in the middle tab. Like, this is the ultimate parent. You have the parent before that, and then, finally the target record. And on the right hand side, we have the logical reasoning on why was this parent recommended and an AI score that we give based on how many hits did we have? Like, did we have a hit on Google? Does our database say the same thing? Does the DNB say the same thing? So based on that, we generate a score of that recommendation. So conclusion, yes, again, to reiterate, this solution has resulted in a 60% cost reduction of the process. It has 57% faster processing. It has, of course, enhanced accuracy. So core wins for us. This was probably our first successful Gen AI implementation. Um, the architecture is really optimized, and we are still improving the architecture on a day-to-day basis. Uh, the data quality is improving over time. Next step, BFO-wide implementation, or like, the Salesforce. BFO is Salesforce, so Salesforce-wide implementation, which is currently ongoing. We are in the middle of this. Direct Salesforce integration, again, this is something we are moving towards, where the process runs daily and directly writes to our Salesforce database. The idea is that this process would be totally automated from start to finish without intervention from anyone, and it would run on a daily basis as soon as at a set time to improve this data.